I've divided Part 2 into 2A and 2B because of its length. So let's begin. Part 2A, the causes of ice ages. Earth scientists have identified the occurrence of 6 ice ages in our planet's history. The first, Pongola, lacks enough evidence to be included by all researchers, and other climatologists claim evidence for others. Still, no one can point a finger to a single cause of all ice ages, and no one knows with certainty what causes them or ends them. Now it's helpful to first figure out what causes global warming, then we can make a few educated guesses about global cooling. Sometimes research is a seesaw. Let's start with greenhouse gases. Water vapor tops the list and is hundreds of times more potent than carbon dioxide as an insulating blanket in our atmosphere. About 60% of the Earth's greenhouse warming is produced by water vapor. The sun's infrared and ultraviolet radiation can penetrate our atmosphere, but they have a tough time escaping back into space. This eventually causes a global heat buildup. Oddly, water vapor was once considered a major greenhouse gas, but no longer. Apparently, water vapor condenses from the atmosphere after only a few days, not long enough to contribute. But just off the top of my head, I would say that atmospheric water vapor is constantly replenished through evaporation, and the warmer the water and the atmosphere are, the more the evaporation. Whose idea was it to disregard the cause of 60% of Earth's warming? Methane is another powerful greenhouse gas. It's about 84 times more effective as an atmosphere insulator than carbon dioxide. In the pre-human years, most methane reached the atmosphere from decaying plants and animals, such as phytoplankton, zooplankton, and crustaceans. And then we have carbon dioxide. There are 720 billion tons of carbon dioxide in the Earth's atmosphere, and much of it comes from volcanoes. 714 billion tons occur naturally, and humans have contributed 6 billion tons, less than 1% of the total volume. So we say that the atmosphere of Venus is 95% carbon dioxide, and the surface temperature of that planet is 847 degrees Fahrenheit. Therefore, carbon dioxide is the culprit. Well, not so fast. Venus is 26 million miles closer to the Sun than we are. What happened to Venus would surely happen to the Earth at that distance. The oceans would evaporate, and the water-saturated atmosphere would have our surface temperatures soaring. Then intense ultraviolet radiation would split apart the water molecules, and hydrogen would float out into space. The remaining oxygen would bond with the abundant carbon on our planet, transforming our atmosphere into a blanket of about 95% carbon dioxide, just like Venus. There are additional greenhouse gases in our atmosphere, both natural and artificial, and we could talk about each one in length, but the debate would remain the same. Is it man-made global warming or natural global warming? To be clear, the Earth's atmosphere is vitally important for keeping away the bitter cold of space, and the billions of tons of carbon dioxide in the atmosphere are required to do that. By the way, the atmosphere is composed of gases that seep from the land and water and are kept from escaping by gravity. Now we know that one condition to creating an ice age is to lower atmospheric gases. If 720 billion tons of carbon dioxide are needed to maintain our current average global temperature, then reducing that load should lower the temperatures worldwide. As impossible as this sounds, it was already done once to great success. At the very beginning of the Proterozoic period, just after the Hadean Eon, the Earth's atmosphere was mostly methane and carbon dioxide. Then along came the cyanobacteria. These ancient organisms blanketed the globe, absorbed most of the noxious gases, and then exhaled oxygen. Before long, these little life forms were the architects of the great oxygenation event. They removed the greenhouse gases and replaced them with oxygen. New organisms then evolved as oxygen breathers, and the Earth cooled precipitously to where our planet became one big snowball. But getting back to the present, on the other hand, even if all human-produced greenhouse gases ceased, would the Earth cool down, heat up, or remain constant? We can only guess. Two other factors that may begin and perpetuate ice ages are continental positioning and mountain ranges. About 40 million years ago, give or take, the Himalayas began their rise. This range quickly became high enough to effectively block warm air currents of the tropics from moderating the air temperatures of Central Asia. Soon glaciers formed, and 6 million years later, the Cenozoic Ice Age began. About the time the Himalayas formed, the Rocky Mountains of North America rose, as well as the Alps of Europe. These ranges blocked airflow from the north and absorbed carbon dioxide from the atmosphere. The results were, and still are, frozen glacial regions of the higher latitudes. Then about 3 million years ago, Panama formed and blocked the warmer currents of the Pacific Ocean from entering and moderating the waters of the Atlantic. Thus, the Quaternary period of the Cenozoic Ice Age began 2.6 million years ago. The towering Appalachian mountain range of the Ordovician period, 460 million years ago, is now credited for ushering in the Andean-Saharan Ice Age, which lasted 40 million years. Continents and mountain ranges are long-lasting structures, which explains why ice ages may endure many millions of years. Thank you for watching. And remember, coming to booksellers for the 2023 holiday season, The Coming of the Seraphim. See you soon.